So we're going to continue with what we did before, dealing with summation, dealing with finding the sum. But this time, instead of writing it like this, find the sum of the first 25 numbers, we're going to do it in summation notation. And what summation notation means, you're going to use the Greek letter sigma. And when you use the Greek letter sigma, sum, it's like an S in the Greek alphabet. And here's what it represents. If you see n, this is the first value of n. So if n was 4, I want it to start with the fourth number in the sequence. And then this represents the last value of n. So maybe I want you to add the sum of the fourth number through the 10th number. So that would be 4 and that would be 10. And then there will be a formula here to tell you what formula you need to use to find the 4th through the 10th number in the sequence. And then that you add them all up. Okay? So let's start with the first one. If you look here, they want you to start with the third number of the sequence and go all the way to the 7th number in the sequence. So I'm going to make a little box. It's kind of like what we did on the first day. 3, 4, 5, 6, 7. And what I'm going to do is you'll notice it isn't an N this time, it's a K. That's okay, or no pun intended there. If this is a K and that's a K, we're good. If this is an N and that is an N, we're good. Normally the numbers that are letters that are used are N and K. All right. So if I show my work, I'm going to go 2 times 3 squared, 2 times 4 squared, 2 times 5 squared, 2 times 6 squared, and 2 times 7 squared. Now, honestly, the most annoying part about this is knowing when to use this notation or how to use this notation. Let's see, so this would be 18, 16, 32, 50, 72, 98. Then what I have to do, because it is in sigma notation, is I need to add them. So I'm going to pick up my calculator, add them all up, dot, 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 and I get 270. Now I can't say the sum of the first 25 numbers because it's not the first 25 numbers. It's the third number in the sequence through the 7th number in the sequence. So I just write 270. Okay. Let's make this a K because that should be a K. If that's a K, that needs to be a K. This time what I'm saying is, okay, I want you to do the first number in the sequence through the 5th number in the sequence. Okay. So I'm going to do the same thing. 1, 2, 3, 4, 5. I go 1 plus 2, 2 plus 2, 3 plus 2, 4 plus 2, 5 plus 2. Okay. The unfortunate thing is that there isn't necessarily a more fancy way to do this if I'm picking random numbers. So I go 3, 4, 5, 6, 7. Since I'm dealing with summation notation, I'm going to add them up. Let's see, 7, 12, 18, 25. Okay. All right. I actually want to change this, and I'm going to make this 103. Okay. So now here's what I'm going to do this time. How is this going to be different than this? This is tangible. I can write down the first through the 5th number. But if you look at number 3, I'm not going to list the 2nd, the 3rd, the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, all the way to 103. That's ridiculous, okay? Because if I started doing that, it'd be too much. But I just want to show you what that means. So I'm going to say I'm starting with the 2nd term, then I'm doing the 3rd, the 4th, dot, dot, dot. The problem is there is no value to plug in, which means there's an imaginary, let me put it in pencil so I can erase it, k to the 0 power. So if I plugged in 2, 2 to the 0 is 1, times 4 is 4, which really means every single time it's going to be 4, 4, 4, 4, 4, 4, 4. So when you have a constant like this, there is this formula that's over here that tells you what you can do to figure it out. So you multiply the constant by how many values there are. Now, if this started with 1, it would be 1 to 103, but it starts with 2. So I have to go 103 minus 2, which is 101, and then add 1, okay? And some of you go, wait, how does that make sense? If you looked here and you figured out the numbers 3 to 7, you would go 7 minus 3 is 4, but you have to count that number because look, how many numbers are there? 1, 2, 3, 4, 5. So if you were figuring out how many numbers from like I don't know, 16 to 73, what you would do is you would take the last minus the first, and you would add 1, okay? And that's how many numbers are in the range. 7 minus 3 is 4, plus 1 is 5. 1, 2, 3, 4, 5. There's 5 numbers in that sequence. So that means times 102. 4 times 102 is 804. That means the sum of the second term to the 103rd term is 408. Okay? Now, this is similar. I don't want to write and go 1, 2, 3, 4, 1, 2, 3, 4, and then add all those up. That's super annoying. And I'm not going to accept it if you do that. So there's a formula. If you have a variable there, a linear variable with nothing being added, it's not going to work if you have a linear variable here because you're adding a constant. But if you just have a variable, you're going to use this formula right here. So if you look, if you want to know how many terms there are, you know there are 30. But if you don't believe me, you would go last minus first, 29, plus 1, 30. You know there's 30 terms. So you're going to take this 30, and that's what's going to go in for n. So you want to know more formulas, you're going to put those in the top of your test. So you're going to go 30 times 30 plus 1 over 2. Pick up your calculator. 30 over 2 is 15. And I'm just going to go in my calculator. Hold on, let me pause. So in my calculator, oopsies, I went 15 times 31, or you can multiply all of it, and I get 465. Which means the sum of the first 30 numbers with this variable is 465. Now, if it's not a linear variable, but it's a quadratic, which means the parent function, you're going to use this formula. And by the way, that should have said n equals 1. So now I'm going to take that 32 and I'm going to plug it in. So I'm going to go 32 times 32 plus 1, 2 times 32 plus 1, all over 6. I'm going to pause it real quick, pick up my calculator, get the answer. In my calculator, got 11440. So what that means is if I add the first 32 terms of a quadratic parent function, I get 1140. Now, the way I remember this, of course, you know I have silly ways to remember things. If you look, this has an n, this has an n plus 1. There's 2 n's, that's why it's divided by 2. It's also the beginning of the arithmetic sequence. And then if you look here, there's 1, 2, 3, 4, 5, 6, and that's how I remember divided by 6. Good morning.